Hey guys, so we're going to cover the multiplication rule in probability. This is just going to be a really brief introduction. Alright, so this rule is going to be applied in this following scenario. Alright, get my head kind of out of the way there. So what is the probability of flipping a coin 4 times and getting heads all 4 times in a row? Alright, so first we're going to try and take an intuitive approach to this, and I'll show you how we can use the multiplication rule. So first, starting off with the intuitive approach. All right, so let's say that we have 112 people. All right, and the question is, what percent of these 112 people would we expect to flip heads all 4 times in a row if they flip a coin 4 times? Well, let's take this in steps. All right, so first off, how many of these 112 people do we expect to get heads the first time they flip a coin? Well, there's a 50% chance that each of these people will get heads, but a 50% chance they get tails too. So we would expect 50% of them, or 56, all right, that's half of 112, to get heads. All right, and likewise, we would expect 50%, all right, we've got these 56 people that flipped heads that first time. They're all going to flip a coin a second time. How many of these 56 are going to get heads on that second flip? Well, again, each of these 56 people have a 50% chance of getting heads on this second flip. So we would expect 50% of these people to actually get heads. So what's half of 56? That's just going to be 28. All right, so now these 28 people are all going to flip a coin a third time now. And how many of these 28 do we expect to flip heads on this third flip? Well, again, they each have a 50% chance, and so we would expect roughly 50% of them to get heads on this third flip. So we would expect about 14 to get heads on that third flip. All right, so now only 14 people out of the original 112 have flipped heads every single time. Now, how many of these 14 will flip heads on that fourth flip? Now, they each have a 50% chance of flipping heads on this fourth and final flip, so we would expect 50% of them, or about half of them, to flip heads that fourth time around. So we would expect 7 of them, 7 of these 14 to flip heads on this fourth flip. And what does this mean? That means that of these 112 people that we started off with, we expect only 7 of them to get heads 4 times in a row. Right, and so what's the probability of flipping a coin 4 times in a row? This is the kind of way we've been calculating probabilities so far. All right, is how many times does it happen out of the relevant total? There were 112, and 7 out of those 112 are expected to flip heads 4 times in a row. So if you go to flip a coin, what's the chance that you will get heads 4 times in a row? Well, it would be 7 out of a 100 chance, or 1/16. That's what this simplifies to. And what is that? That's 25, 12 and a half, about a 6% chance. About a 6% chance. All right. Now there's another way that we can think about this. All right. So we can think of ourselves as starting off with 100% of our 112 here. 100% is just noted as 1. How many of these people will get heads the first time? Well, half. All right, half of this. How many will get heads the second time around? Half of half. Okay. And how many the third time around? Half of this 1/4. What's half of 1/4 but 1/8? And how many of these people, so only 1/8 so far, have flipped heads 3 times in a row? Or in other words, 14 out of 112, that would be 1/8. And how many of these people would we expect to get heads on the 4th time? Well, half of 1/8, or 1/16, which is exactly what we have right here. Right, so in other words, all that we really are doing when we get these numbers is we're multiplying the chance of getting heads on each of these flips. All right, we had 1/2 times 1/2 times 1/2 times 1/2, and that equals 1/16, and that's what we got here. Right. So now this first one is the intuitive approach, but we're going to try and get out of these actual numbers and into just fractions and probabilities a little bit more like what I was doing right here. So what's the probability that somebody gets heads on T1, trial 1? 1/2. What's the probability that somebody gets heads on T2 or trial 2? 1/2, and so on. Every time you flip a coin, you always have a 1/2 chance or 50% chance of getting heads. Okay. Oh, sorry, got ahead of myself. So we're going to use this. Now, our original question, again, is what is the probability of flipping a coin 4 times and getting all heads, or getting heads 4 times in a row? Now, that's the same thing as this question. What is the probability of getting heads on trial 1, and heads on trial 2, and heads on trial 3, and heads on trial 4? What is this big, massive probability? Well, it's going to be nothing other than the probability of getting heads on trial 1 times the probability of getting heads on trial 2 times the probability of getting heads on trial 3 times the probability of getting heads on trial 4. Or in other words, and here's our general rule. Let me just go back for a second. So that's what I have right here. This is what we did on that last slide. All right, 1/2, that's the probability in trial 1. 1/2 is the probability in trial 2. 1/2 is the probability in trial 3, and so on. Now, in general, though, here's the general rule. What's the probability of event 1 happening, and event 2 happening, and event 3? And it can go on. Well, what that's going to be equal to is just the probability of event 1 happening alone times the probability of event 2 happening alone times etc. All right, so that's the multiplication rule in general. We're going to apply it to things other than coin flipping when we do the live session.